Back on March 17th, I made a video about an oil and filter change for this 1970 Mercedes 280 SE, and at about 6 minutes and 28 seconds into the video, I showed a little white sample bottle where I took a sample of the engine oil before I drained it, and wanted to make this video to show you guys why I did that. The reason I did that is so I could have the oil analyzed, and just like when you have your blood analyzed at the doctor's office, to check for things like high cholesterol and stuff like that, you can also have engine oil analyzed to give you a really good idea of what's going on internally in the engine without tearing it down. And what we have here is a complete spectrochemical analysis of the engine oil. And I'll try to zoom in so you can see what kind of things we can pick up on. It's divided into several sections. You've got a wear metal section, then you have contaminant metals, multi-source metals, and your additive metals. And down on the bottom you've got some of the sample information, more contaminated information, and some of the fluid properties, mainly the viscosity and TBN, total base number, of the oil. Judging by the green, red, and orange coloring on here, you might think there are some problems. There's not really as many problems as you think there are, but there is one main problem I have to look at. But let me go through it sort of step by step here. On this particular sample, we had 17 parts per million of iron and about 51 parts per million of lead, no tin, and just a touch of copper and aluminum. And you might ask yourself, well, where would the lead and tin and copper be coming from? Well, that's actually Babbitt material or bearing material. And I can show you over here on this piston. I have out of a old Chrysler 318 V8 sitting here, and right here we have the rod bearing, and you can clearly see the tri-metal material where you have copper, tin, and lead as this bearing wore away and sort of self-destructed. And the reason they used the lead is, as you can see here, it's for embeddability. Particles can actually embed themselves in the bearing material, as you can see, one here and one there, and still have a fairly smooth surface. So the bearing is sort of designed to sacrifice itself in the event that the oil film breaks and you get some particles floating around in the oil stream, and they get between the journal and the bearing and embed themselves. So you do want to have a rather compliant and soft material to do that. And so that would be the source of where some of these materials are coming from, bearing wise. Other sources would be from the piston alone. You've got the cast iron connecting rod, of course, and then you have aluminum from your piston, or in my case maybe the engine head. I've got aluminum heads on that engine, and you've got some chromium on your oil ring, and then you have your two compression rings that would just be steel. So just from the piston alone and the cylinders, you can get a really good idea of where some of these contaminants might be coming from. So you might say that in this particular case we're in big trouble. We have high values of lead, but in reality this engine is pretty old, and it was made back in the day when leaded gasoline was the norm. So that engine was running leaded gasoline from about 1970 to about 1982, so 12 years, and I wouldn't be at all surprised if there were still some residual lead left over in the engine making its way down into the oil. And the key to help determine that is not really any one particular wear element, but the combination of elements. is really the best way to determine what's really going on. You really only have one high value for lead and maybe a medium value for copper and nothing for tin. And with a bearing like this, you know, if you were to have a high value of copper coming from the bearing, you would pretty much have a completely shot bearing. If that lead were coming from the bearings that high, you should see higher values of some of these other elements like tin and copper, and you really don't. So that's what leads me to believe that the source of lead is probably coming from the leftover tetraethyl lead in the engine back when the car was using leaded gas. I'm not really too concerned about the lead. One of the other things that they check for is fuel dilution and water contamination, or glycol for your antifreeze. And in this case, we don't really have any water contamination, so we know the head gaskets are in good shape, but that's not really true for the fuel dilution. We have roughly 4% fuel dilution, which is very high for a gasoline engine. And with just a 7-quart capacity, that's almost a full quart of fuel, raw fuel, dumped into the oil. And if you guys have ever used gasoline to clean parts, you know what a good solvent it is. And the effect that that has is it thins the oil. And sure enough, over here for our viscosity, our kinematic viscosity is only running at around 11.7 centistrokes at 100 degrees Celsius. So the 10W40 oil has now slipped out of grade. It's now 1 grade lower at 11.7. Over here I have a viscosity chart, if I can get the camera to focus, where you have your 30 weight running between 9.3 and 12.5 centistrokes. So we're basically 1 grade lower than we should be because of the fuel dilution. So that's one thing that I really need to look at with this motor. I did have a problem with this engine a while back in the winter time, where I have bad ignition cables to the point where you can actually see arcing between the cables and the cylinder head sometimes in high humidity conditions. And on several occasions the engine was running on about maybe 4 cylinders out of 6. So that's dumping raw fuel into the cylinders, not combusting, which may be contributing to some of the fuel dilution. I have a hard time believing that that much gas would be pumping past the rings. I'd have a lot of blow-by in that case. But it's definitely something worth looking at. And the other potential problem might be that this car is fuel injected, and it's a mechanical fuel injection pump just like you have on a diesel, and the injection pump is lubricated as part of the engine oil circuit. And what I fear is that there might be some bad seals or O-rings in that injection pump, letting the fuel mix with the oil to high levels. So I'm going to have to look at that too, but I'll start off with the ignition wires first and shorten my sample interval and maybe to about 6 months. And instead of changing the oil, I'll sample it again, and I'll see if I can get that fuel dilution number back down to a reasonable value. That's very concerning. There's not really anything wrong with the engine. The engine was very well protected. We're still, you know, a lot of people run a 10W30 or 5W30, so the viscosity change is, although it's not desirable, it's still well within a good range for good lubrication. And our anti-wear additives, our phosphorus and zinc, are still very high, right where they should be for API SL oil. And also for our iron and some of the other wear elements are still rather low. So the engine hasn't been damaged or anything like that. It's not wearing out excessively. But this report just serves as a warning that there's something going on here that you might want to take a look at down the road to help avoid potential engine damage by fixing the problem right now. This analysis report was $25, and it's $25 well spent, because without going into the engine at all and taking out the plugs, doing compression checks and things of that sort, you can see exactly the condition of the engine and what's going on with it, and what kind of problems you might be having before they start, before they develop. So it's $25 well spent, because I had no idea that I had this kind of problem going on, that my oil was basically being diluted by excessive fuel dilution. The alternative is you can change your oil every 3 months or 3,000 miles and not do the analysis and not be aware of the fuel dilution problem, and until it's too late and you start getting a rot knock and you destroy the engine. And I just don't want to do that on that nice engine. It's all original, never had any work done on it. It's been in very good shape, and I want to try to keep it that way with these oil analyses. You don't have to have an oil analysis done just on engine oil. You can also do it on transmission fluid and rear end fluid, and as well as engine oil. And I've done that over here on my for my 1991 420 SEL. Over here we're looking at the differential lubricant analysis report. When I got the car about a year ago, I analyzed the fluids of the entire drivetrain, the differential, the engine oil, and the transmission fluid, and just to assess the condition of the entire car basically. As you would expect for a differential, you've got higher levels of iron. You don't really have any oil filter or anything like that, so we're running around 296 parts per million of iron. But that's actually not abnormal for a differential. Just for comparative purposes, this analysis report for the engine oil, fuel dilution is normal. It's right where it should be. It's hardly even registering. And that's where the 1970 should be also. So that's my goal, is to try to hit that number or lack thereof. Iron is very similar, 15 parts per million, whereas on the 1970 we had 17, so that wear is quite normal. And look at the lead value, almost negligible at 2. So we don't have any bearing wear going on practically. And this car, being a 1991, would never have had any leaded gasoline in there to begin with, because it has catalytic converters. So none of these reports have anything flagged as being that unusual. So I know the drivetrain on that car is in very good condition. So between these 3 reports and just a $75 worth of analysis and a little bit of extra work, I have a complete diagnosis of the entire drivetrain on that car, and I know what kind of condition it's in before I start. And I can keep this up and keep analyzing the oil every time I have it changed, and monitor the condition of all these components to be able to preemptively fix problems before they happen. So there you have it in sort of a nutshell, why I took the oil sample and what it means, and what an oil analysis looks like, and how important they are and crucial they are as good tools to help maintain any car basically, but especially the older classic cars, where it's very important to keep those things running, because parts really aren't made anymore and aren't really that available. So hopefully this will help you guys out and help you guys understand a little bit more, and maybe you might want to do your own oil analysis.